Hello, hello. Thank you for joining our stream today. I'm going to bring on our guest, our Director of Engineering, Oscar Spencer.
Hello, hello.
Hey, Oscar, how's it going?
It's going great. How are you doing?
Doing pretty well, thanks.
Yeah, no, I am so excited for this. I love talking about WebAssembly. You probably know that, but so I'm super duper excited to just have a good time chatting about some WASM today.
Yeah, same. Yeah, and WASM, for anyone who doesn't know, is a shorter way of saying or writing WebAssembly. So let's get into it. So something that when I was learning about WebAssembly, something I kept stumbling over were words. And it was that, Inigo Montoya, you keep using that word. I do not think it means what you think it means, because these words were getting used like they meant something that they don't, most of the time. So I would love to talk about some of those.
Yeah, absolutely.
So tell me about serverless, because serverless sounds like it means no server. But it actually means it's a server you don't have to have your own like DevOps for.
Yeah, more or less. So yeah, it's a super funny term, especially how we throw it around in WebAssembly. But yeah, the whole idea is just, hey, I have some code, and I want it to run somewhere when something happens. That's really all it means. There's a server, there's a computer out there somewhere that's gonna run your code, but you don't care about that computer whatsoever. You don't want to maintain that computer. You don't want to make sure it's online. You don't want to do any of that. You just say, hey, I've got some code. Run this code for me, and it says, all right. It's just some black box that just runs some code, and you're only paying usually per function execution or something like that. You're not paying to just have a server sitting around for you all day. So it's a pretty fun way to think about computing, and it's really great for developers, especially as a lot of times folks just don't want to think about actually deploying their code somewhere or where it's actually running. Folks just want to get some code that's running. Just want to write some code.
Yeah. Well, okay. So that sentiment, like that motivation, makes sense. I still have beef with calling it serverless.
Right.
But okay, we'll go with that. And we've got a question from Ramon, which I will show here. So, hi all, what does ELI5 mean?
Yeah.
Do you want to take this one, Oscar? Or?
Yeah, I'll go ahead and take this one. Yeah, ELI5 stands for Explain Like I'm 5. So the whole idea behind this series is we're going to just be breaking down these concepts as far down as we possibly can, just putting them in super duper simple terms where you're going to feel like, oh, you know what? I understand that. Even if you have no knowledge of what any of this stuff is, even if you're not a technical person, you should be able to come out of this feeling like you understand everything that's going on.
Exactly. Yeah. And it works out as a super nice shorthand for people who have seen it before and know what it means, to say, this is the level of explanation that I would like to get from you right now. So I'm really glad that exists.
Absolutely.
And okay, so now how about edge computing? Because to me, I mean, this one is a little bit less cut and dried than serverless, which, but edge computing, like, to me, intuitively would mean something that's happening. It's like compute that's happening like far away, but it's actually compute that's happening as close to the user as possible or something.
Yeah, I mean, it really depends. It depends on how you think about it. So in a traditional computing environment, I have some web server, I have my own computer, and I'm running some code on it. And when you want to talk to, my web server, your request, no matter where you are in the world, has to traverse all the way around the world and reach it to my computer and send you a response all the way back. And so the whole idea of edge computing is, can we actually do that computation close to where the user exists? So for example, if I have a server here in Boston and I have, some user in India who wants to communicate to that server, it's quite a bit of a journey to, make that hop. But if I actually have a server that sits right next to that user that can respond to that request, they're going to have a much better experience. They're going to have, much lower ping time, that sort of thing. Just, amount of time it takes for that request to actually make it back and forth. So depending on how you look at edge computing, technically it is far away. It's far away from my origin server. So I might have my server sitting right here, from me, and maybe my server's telling those edge compute servers how to do their job, and they're very far away, right? But yes, they are very close to the individual users themselves.
Yeah. So it's on the edge from the perspective of the server.
Mm-hmm.
Is that right? Yeah.
Mm-hmm.
Okay. So
and
that works.
Yeah, and in WebAssembly, and we'll definitely get around to this later, WebAssembly is very well suited for this kind of computing.
Yes.
And so we'll definitely get into that, though.
Yeah, for sure. Okay, and now Sandbox. So to me, Sandbox sounds like something sort of like playful and very ephemeral, right? It's something, because sand, it doesn't keep its shape, right? That's kind of the point of sand. You know what I mean? But it's used in a way that makes it sound a lot more like a firewall. And it's like they mixed up Sandbox with Sandbag. Because a sandbag, right? That's something you would like pack in place to like keep something from escaping or whatever. And that sounds like the way that Sandbox is actually used. Is that approximately right?
Yeah, I mean, it depends on how literally you want to take the analogy. Where I usually take it very literally, to think of, a sandbox. Imagine a child, playing, and there's like a box of sand, and fairly large. And you take that child, you sit them in it, and they're playing around. They're having a good time. They're in their own little world. Like they're messing around, they're building stuff, they're having a good time. But the point of the sandbox is to keep the sand from getting everywhere, right? The idea is to contain, it's tough. I understand. Like, it's tough whether the sand's actually.
And that's not what happens.
Yeah, no, it's not what happens, right? But imagine a magical sandbox where the sand never actually leaves the box. But if you can imagine yourself as a child, when you went and you played in these sorts of environments, you really felt like you were being transported into another world. You weren't interacting with the outside world. Everything that you were doing was happening in this sandbox. And that's exactly,
I really like that.
Yeah, that's exactly what it means in WebAssembly too. It means that, hey, we're going to be doing some computing. We're going to go look at files. We're going to go like mess stuff up as much as we want, but it doesn't touch the outside world. Nothing I do inside the sandbox touches the outside world. Of course, asterisk, asterisk, asterisk on, are there ways we can reach the outside world? Are there ways we can throw some sand outside the box? Yes, but WebAssembly gives us nice abilities to do this in a nice controlled way, where, maybe telling your child, hey, you can throw sand outside the box at this time, and I will give you 12 cookies, and they might actually wait. But, still TBD, of course.
Yeah. Okay. So that totally works for me. The idea of the magical sandbox that more or less contains the sand, and also the perspective of the kid sitting in there making, your own little world. And that totally does work for me. Thank you.
Yeah.
Okay. So JavaScript. What should we know about JavaScript before we start talking about WASM?
Okay. So I am very biased. For those of you who do not know, I do work on a programming language for WebAssembly that compiles directly to WebAssembly. And so my biased opinion is there's nothing you need to know about JavaScript to do WebAssembly. And in a certain sense, that is true. There are lots of people who are doing WebAssembly not inside of the browser at all. And in these cases, a lot of the times there is no JavaScript that's happening whatsoever. But I'd say, usually the question that comes up is WebAssembly going to replace JavaScript? How do they work together? And the answer to that is, yeah, in the browser, it's, JavaScript's not going anywhere. It's going to exist. JavaScript and WebAssembly can live hand in hand together. So you can write some JavaScript code, it can talk to your WebAssembly code. If it's a WebAssembly code, it can talk to your JavaScript code, and they can exist as best friends. So I'd say, JavaScript's really only important in the sense that it can tie some WebAssembly modules together. It can provide some functionality that WebAssembly doesn't have yet, but particularly in the browser. Typically on the server, we're doing things with WebAssembly runtimes directly to make all this stuff happen. But yeah, I'd say in general, don't worry too much about JavaScript. If you're not a JavaScript person, either you're trying to get into development or you're already a developer, you don't need to worry about knowing JavaScript to get into WebAssembly. Absolutely not.
Okay, sounds good. And runtime. Now this one I wasn't confusing it with, another word, but like what is that? What is runtime?
Yeah, runtime means a lot of different things to a lot of different people. The way
Oh,
that I like, I know, yeah.
the
The
best.
way that I like to break it down, and in particular, when I give this answer, I'm going to speak specifically about WebAssembly runtimes. But when we say WebAssembly runtime, we mean the actual computer program that is executing the WebAssembly itself. That is what we're talking about when we say runtime. So examples of these runtimes are WASM time, WASMer, WASM 3, WASM Edge, the WebAssembly micro runtime. There's a million of these different, not literally, but there's quite a few of these different runtimes that exist. But that's an important thing to understand. A joke that's thrown around in the WebAssembly community all the time is that WebAssembly is neither web nor assembly. So you might be asking yourself, hey, well, if WebAssembly is assembly code, I thought a computer would run it. Why is there a program that runs this? And it's because WebAssembly is not actually assembly code. But yes, I'd say, a WebAssembly runtime is simply a program that executes the WebAssembly. They're really freaking good at it, and it's going to run probably just as fast as a computer just running raw code. But it's still a program that has to exist to run that WebAssembly code.
Gotcha. Yeah. Okay. So that works. And how about performance? What does performance mean in the WASM context?
Yeah, a lot of people, especially in the early days of WebAssembly, were really concerned with performance, especially people, writing apps in the browser. One of the things we see all the time are these benchmarks of JavaScript framework versus JavaScript framework. Like, hey, will I get the fastest apps if I write in React? Will I get faster apps in Vue? What if I don't use a traditional thing at all? What if I use something like Svelte, which is this compiler that compiles your code into very, very efficient JavaScript? And so a lot of people are super concerned with how can they get the fastest apps. And that's where people thought WebAssembly would come in was, hey, well, it's not JavaScript, it's assembly code. It can run much faster than JavaScript. So therefore it would be more performance, right? But I think performance can mean lots of different things here. Do we care about how fast that code makes it to the user? That might be your benchmark of what a more performant app is, right? Where like if I have an application that is 3 megabytes of JavaScript, which doesn't sound like a lot, we've got phones these days, you get a terabyte of memory in your pocket, but in terms of like downloading a website on your computer, 3 megabytes is actually pretty hefty. That's a pretty hefty website. That might add an extra half a second to load that web page versus the same program written in pure WebAssembly might only be, 100 kilobytes. In which case, if it can make it to your computer in a matter of milliseconds versus a full half a second, then yeah, it's more performant. So you can talk about performance in terms of just like literal network latency of actually getting those bytes to your computer. You can talk about execution speed. How much faster do my WebAssembly programs run than programs written in other languages? Which is typically, I imagine, what people are talking about when they say performance. And then, of course, throughput, right? If I have some server that's written in some traditional language versus some server that's maybe running a bunch of WebAssembly modules, which one can handle the most number of requests per second, right? And so these are a lot of the things that folks are considering, with WebAssembly are, hey, maybe I might write this Rust server and it's super freaking fast. It can execute, 10,000 requests per second. And I did this WebAssembly app that can only do 5,000 requests per second. So WebAssembly is slower here, but do I get great benefits that, outweigh the fact that I'm losing this on performance? So performance is definitely something people talk about in the WebAssembly world. And I think for me anyway, I think it's something that folks don't need to worry about too much right now at all. It's still a brand new technology. There are loads more we can do with it. There's so many performance gains to be made all across the board in all the areas I just mentioned. But yeah, folks just don't worry too much about performance. Like worry about what you can do with WebAssembly right now rather than just trying to be ultra fast with everything.
Mm-hmm. Mm-hmm. Yeah. Okay. Yeah. I guess for me, when I was first learning about WebAssembly, one of the performance, that's one of the biggest things that is sort of harped on, like,
Mm-hmm.
oh, it's just so performant, it's so performant. And I'm like,
Mm-hmm.
cool, but like, in what way is it performant in a way that I care? You know
Mm-hmm.
what I mean?
Yeah,
And so it's
absolutely.
still, Yeah, even if I wasn't worried about like optimizing the performance, it was still like I needed to know why, it mattered or
Yeah, I
whatever.
mean, in some cases, it matters a ton. Where, and
Mhm.
I think, I mean, we might get to this, we might not, but one use case for WebAssembly that people are talking about day in and day out is WebAssembly going to replace containers, like Docker containers. In which case, like, yeah, WebAssembly would be far more performant than a Docker container. Spinning up a Docker container is a lot of processing power, a lot of work, a lot of energy just to do that sort of thing versus a tiny old, WebAssembly module, right? In which
Mhm.
case that might be something that's immediately relevant to you. And maybe you might be thinking, you know what, I don't care about Docker, it's still not relevant to me. But maybe in terms of all the services that power your everyday life, can these web servers talk back to me faster? Am I able to get
Mhm.
my job done faster? These are sort of the things that WebAssembly might be helping out with in terms of performance right now.
Uh-huh.
So those are things
Yeah.
to maybe consider. But it is
Yeah.
very difficult for an individual person to try and think through, why is this better for me? It's definitely very
Yeah.
difficult.
Yeah. I've also seen questions where people are, like clickbaity headlines. Is
Mhm.
WebAssembly going to kill JavaScript? Is
Oh yeah.
WebAssembly going to kill Docker? And so what I realized is I think that means WebAssembly is a millennial, right?
Yes.
Because it's apparently going to kill off all the, I mean, it's not, right? Because, right. But yeah, I felt like some kinship with WebAssembly in that moment.
Oh yeah.
Um,
Absolutely. I'm going to start using that actually.
okay, and so hat tip to Dan Myers, who's a math educator for this framing. If WebAssembly is the aspirin, what is the headache?
Yeah, there are a number of headaches. Um, I'd say the first and foremost headache that everyone might have had thinking this is people just hate or love JavaScript. At the end of the day, there are people who adore JavaScript. Twitter will tell you, by the way, there are people who absolutely adore JavaScript. And in my personal opinion, and this might come as a shock to many people, I adore JavaScript. At the same time, I think JavaScript is both a garbage language and also a brilliant language at the exact same time. And I find myself, there's like all the like little tricks and things that you can think of with JavaScript, but just thinking about the history of JavaScript, how a language designed in a week or two has become this thing that powers the world is truly incredible, right? Um, and then, of course, you have people who absolutely hate JavaScript. There are people who despise it. They're like, this is terrible. I get all these type errors all the time. This is ridiculous. I never want to write this language ever again in my life. And so a lot of people come to WebAssembly thinking about it that way, saying, hey, this is something that can replace JavaScript in the browser. For years, I have heard folks coming to me and saying, yo, if I could write Python in the browser, I would lose my mind. Like if I
Okay,
could,
yeah,
yeah, yeah, yeah.
I'm right there. Yeah.
Right.
Mhm.
And one of the immediate things that WebAssembly enables is we can write languages that are not JavaScript that can run in the browser. And of course, a couple people might be thinking, oh, well, aren't there languages that already exist that run in the browser that aren't JavaScript, like Elm, for example, or Rescript or ReasonML, languages like this. Or back in the day, CoffeeScript. I don't know if anyone, that's a throwback. Um, you know, and these languages, yes, they do all run in the browser, but the important detail is that their compilers compile the language to JavaScript, which means typically, and actually, these compilers have done an excellent job of avoiding it, but a lot of the time that does mean your language is going to inherit a couple features from JavaScript that maybe you weren't quite ready for, or maybe you didn't want in your language. But with WebAssembly, just thinking of it as an assembly language, you can just take any language that can be compiled. So, think of, your Rust, your C, your Go, languages like this. It's very easy to get them to run in the browser using WebAssembly because you can just compile them to WebAssembly code. And for languages like, Python and maybe something like Ruby, you can make it work. You can write a runtime for these languages that compiles to WebAssembly, and then you can run those languages in that runtime in the browser. You can make all this stuff work. And in fact, the projects that are, Python in the browser, Ruby in the browser, they're super popular. People are very excited for these projects. It's like, wow, I can really get out here and start doing things. So yeah, the number one headache is I don't want to write JavaScript in the browser anymore. Stop making me do it. That's the number one headache. But then there are a couple of other brilliant use cases that we're using WebAssembly for these days, which is security and sandboxing. I say that's sort of a really big one, where how can I execute someone's arbitrary code in a safe way that doesn't destroy my life.
Right.
That's difficult. You can never ever just take code from someone and just run it on your machine. I think that's probably something that they teach in school now is, hey, if someone sends you a bash script or a .bat file, don't just download it and run it. Like, don't do that, right? That's something that I think they're actually teaching folks these days. But
you mean when you say in school, you mean like in computer science school?
No, I mean like in primary school, like when you're taking like a computers class. No, okay, well that's maybe a little scary then. But like I was hoping that folks would, maybe not. But like that's not something that's safe to do. It's not safe to run code from strangers. It's not safe at all.
It's like it's the new stranger danger.
Right, exactly. But unfortunately, sometimes it's kind of important. Sometimes you could build really amazing applications if you could run code from strangers. And so the question becomes, is it possible to do so safely? Can we safely run code from strangers? And that's the interesting question. So of course, some folks, their mind might go to, oh, maybe I can use something like Docker. I can take a Docker container, I can lock it down, make sure it's never reaching out, to a network or something like that. And like there are some things you can do there, but I think the issue that folks see with it is it's very difficult to lock it down and make sure that you're actually catching everything. You have to think of every single possible way some program could reach outside of your Docker container and talk to the world and shut it down. And you might miss something, and that would be terrible. Versus with WebAssembly and having a sandbox, it's the exact opposite. There are no features. There is no way to talk to the outside world, and I can add abilities for you to do so, right? We can start saying, hey, I will allow you to talk to this one web server. I will allow you to access this one file, right? And so when we start thinking about, security from this perspective, then all of a sudden it's pretty safe. Where if you send me some code where I just give you no capabilities whatsoever, you can't do anything on the machine at all, right? I can safely execute that code. The worst thing that'll happen is the code runs in an infinite loop. That's the worst thing that happens. And, I just can say, okay, stop. And that's it. But I can be very confident that, if this program was trying to mine Bitcoin or something, it wouldn't be able to reach out to the network and broadcast, hey, I did this thing, go send this money over here or whatnot. That's not something that you would be able to do by default with WebAssembly. And so I think those are the major headaches. People want, some diversity in terms of, languages they use to develop the web. I think you see, as much as people hate them, we got frameworks like Electron. People hate Electron apps. Electron is it's a project that allows you to take any website that you've built and run it as a desktop application. So popular applications that use something like this, I don't know if they use Electron exactly, but Slack, Discord, probably half the apps on your computer are Electron apps, where developers just want to build a website and ship it as an application, and that's perfectly fine, except people hate it in the sense that they got to run a web browser for every single app on their computer. But this shows the pervasiveness of web computing, and so we need to evolve the web. JavaScript, amazing, it got us here after a long time, but having access to far more languages allows us to then think about the next point that web computing can go. What can we build websites with nowadays? A sneaky Chrome in disguise. Yes, absolutely. That's exactly what it is. But that's the power of WebAssembly, and that's why folks like me are betting everything on WebAssembly, whether it's their free time to work on open source, whether it's their daily life working at a company, just working at like a startup to do WebAssembly. It's like WebAssembly is sort of the future. We know the web is going to be here; it's not going away, right? But we're going to need more things than just JavaScript to, keep evolving in the future. So yeah, definitely quite a few headaches that WebAssembly is solving for us.
Yeah. That's something that I'm particularly excited about. So that now that I'm starting to grok what WebAssembly is, like, it is super exciting to be on like the frontier. I mean, like a non-evil Lewis and Clark kind of situation, you know?
Oh yeah.
Yeah. So why is WebAssembly the one to bet on instead of something else?
Yeah. So if you weren't going to use WebAssembly, we mentioned like for the arbitrary code execution, you might use something like Docker, maybe there's like V8 isolates. So V8 is the JavaScript engine that powers Google Chrome, and so every other browser. And there's a way to run it in a mode where it's pretty locked down. So there's potentially, that sort of, use case there. In terms of, using something else, you use something like the JVM. One of the things we haven't talked about yet is portability, right? And that's a huge thing with WebAssembly, where if you write a WebAssembly program, you write it one time, you compile it, you get a WebAssembly module. That WebAssembly code can then go run in any single WebAssembly runtime that exists. Asterisk.
Which is many.
Yes,
right?
Which is many. And so when you think about it this way, it's write the code once, compile it, and then go ahead and run it anywhere. Which, if you've been in computing for a while, you realize that's kind of the slogan of Java. It's write once, run anywhere, right? Where this was like the whole idea was instead of going around and compiling, for multiple, different targets everywhere. In fact, so anytime you go on a website, you go to download some software, you see, oh, download for Windows or download for Mac or download for, Linux or whatever. That's not a thing with WebAssembly. And the way we bundle Java, it is a thing, but fundamentally the Java code itself, you can just download the Java code and run it yourself, but no one would ever do that. We do package it in a way where you download it for whatever operating system, but the fundamental concept is there, where you write the code, you compile it once, and that's it. There's no worrying about compiling it differently for different systems, and that's true for WebAssembly as well, which kind of brings to the point of, hey, well, why aren't folks using the JVM then? The JVM already solves all these problems. I think it's just that the JVM is a bit large. It wasn't designed for the use cases we have today of trying to be very small, portable, and efficient. So
Did
Java.
we define JVM already?
Oh, sorry. Yes, the Java virtual machine. It is the runtime for Java. It is the thing that runs your Java programs. Yes. And so, yes, it's just that Java was designed a long time ago. That's sort of simply it. And so WebAssembly is like and people are going to hate me for saying this, but it's like a very lean, mean Java in a way, in terms of being the JVM, not Java itself. But, lots of different languages can, target it, and they can say, hey, I want to compile for WebAssembly. And then all of a sudden you can run everywhere. And then we can have interoperability between loads of different languages. You can have an application written in Rust, written in C, written in Python, written in all these different languages, and it'll just work. You don't have to worry about, oh, well, that doesn't work in my ecosystem, right? We can start pulling from everywhere. So imagine a place where, like, you might choose a language because of its ecosystem. Imagine you can use components from any language's ecosystem. That's when we're going to see this new boom in computing and a new way that people consume open source. It's going to be absolutely insane.
Yeah. Yeah, so Gawar says, when I compile a WASM module and it could run in all WebAssembly runtimes, I would still need the capabilities, or are they two separate things here?
Yeah, that's a great question. So yes, the capabilities would have to be configured per runtime. So that particular runtime it's the thing that's providing the capabilities. So those runtimes are going to have to say, hey, I'm allowing you to do this. I'm not allowing you to do this. And in fact, the way that we handle capabilities today in WebAssembly is typically through this thing called WASI, or the WebAssembly System Interface. And it actually handles these cases really well, where it will tell the module, hey, no, you don't have permission to do that thing. And that's something you could handle in your code if you're not allowed to do something. But yes, those runtimes would all have to be configured separately. I do think, though, there is a proposal in process to have a standard way to define what capabilities you want WebAssembly modules to have. And we could potentially even write that into the WebAssembly modules themselves, so they can request, hey, this is what I want from the runtime, and it can sort of just report back very quickly, no, I'm not going to support you. Or sure, I will support you.
Cool. And so is WASM actually faster than things like JVM and V8?
Yeah, that's an excellent question. This is something that folks ask me all the time. Again, going back to performance in the browser, I want to rewrite my application in WebAssembly so it runs faster. Does it actually run faster? And I hate to break it to folks, but actually, in a lot of cases, no. Either WebAssembly is about the same speed as your application. Maybe it's a bit faster in some cases, but it's not really faster than just writing an application in JavaScript. And that might sound surprising to some folks, but the important thing to sort of understand here is we've had JavaScript for ages. And if you pay attention to the V8 team and the content they're putting out, maybe like every 6 months or so, there's a new blog post about this crazy new optimization that they've written into V8 to make JavaScript fast. And so JavaScript is a really freaking fast language. The other thing to consider is how we actually use these applications in practice. So when you go visit a website, you load the page and then you probably start scrolling. The moment the web page is loaded, you're not clicking on something. You're probably moving your mouse to a particular place to click on something. You're looking around, you're scrolling the page and whatnot, in which case code is running when you actually do something. And so one of the major performance metrics that is touted about WebAssembly is WebAssembly is so fast, WebAssembly can be decoded and start running before JavaScript code can even be parsed. And that's absolutely true. That's completely true. Your WebAssembly code will start running before the browser even understands what's going on with your JavaScript. But the point, though, is that you're not actually interacting with that code until you actually need to use it. And of course, there are cases where that it actually matters. Maybe like on YouTube.com, you're watching a video and there's some video encoder that's running in the background. Maybe you write that thing in WebAssembly and it will be twice as fast as JavaScript. But that's not the case for most people's applications. So that's why I keep going back to right now, unless you really see I am going to fundamentally re-architect how I'm thinking about my problems and solving them with WebAssembly, you can get significant performance boosts. But do not rewrite your apps in WebAssembly for the sake of rewriting them in WebAssembly. You're not going to get the performance boosts that you expect.
Maybe a security boost. That's maybe more of a guarantee.
Yes, exactly. And it's sort of more using all of these different features of WebAssembly where you say actually, I need to have an application where maybe I want my users to write some code and I want to run it for them. Right. And I need to do that in a safe way. Yeah, absolutely. Switch to WebAssembly for that. Have, embed some WebAssembly runtime into your application to do that. That's a beautiful use case of WebAssembly. Or, hey, I need to have these, like my JavaScript, modules or whatever are just way too big. I need something smaller to ship, right? Depending on maybe you're trying to run on a microcontroller or something, or maybe you're trying to write some code that runs on a light bulb, right? Like in these cases, it's like, okay, it makes sense to use WebAssembly because I can get extremely tiny modules that are going to fit and be able to run and be very efficient, right? And so these are the things, like all the other features of WebAssembly is what people should be caring about, right? That sandboxing, that security, that binary size, that's the stuff people should be focusing on right now. Performance will come, I promise. In the future, we will get to the point where, yes, WebAssembly is just faster than everything else. But right now, we really should be focusing on all these other use cases.
Right. Right now, it's sort of merely as fast for the most part as everything else with all these extra security and portability features. Yeah. Okay. So we've talked about the sandboxing and that's one of the ways that, or that's one of the things that the characteristics that makes WASM so secure. Are there any other characteristics of WASM that add to the security value?
Yes. So sort of getting back into capability management and the WebAssembly system interface, the whole idea of what WASI is what we call that. The whole idea behind it is to provide WebAssembly modules with a way to communicate with the outside world. So if you're familiar at all with sort of how like operating systems work, they're sort of akin to system calls where there's like programs running on your computer can't actually do too much without asking the operating system to do something. So for example, if you have a program that wants to open a file, well, actually it's your computer that manages files. Your program isn't going to just understand how to talk to a file. So, your program's going to ask your operating system, hey, can you like open this file for me, please? That sort of thing. And so with WebAssembly, not only can we have basic capabilities like, hey, can I make HTTP calls, right? Like maybe that might be a basic capability. We can get way more granular. Those WebAssembly runtimes can actually go very specific in how they want to implement all of these system calls. So for example, we can say like, actually, you're only allowed to talk to, api.com forward
Mhm.
slash query or something, right?
Mhm.
We can get very freaking specific with it, and that's something that you can technically try and build with other systems, other languages. But it's going to be terribly, terribly difficult. Versus this is like core functionality of WebAssembly.
Mhm.
WebAssembly allows us to think about these things this way. Or even going back to files, abstracting away a file system. Like if you're trying to do something like, hey, actually, I'm going to securely move files into my system via some, special protocol or something like that. That WebAssembly module then with the runtime can only get access to those specific files that it needs, right? Like you're not worried about accidentally leaking something you're not supposed to, especially thinking about like, again, like all of these leaks that we've been seeing lately of like, oh, hey, unfortunately, your if you're an American, your social security number got leaked because of like some leak or something, and it's terribly annoying, right? And there are different points in the system where things break down, but if one thing we can do is just not let code accidentally have access to sensitive information, we probably are going to
Mhm.
have a little bit of a better time, right? And so
Mhm.
WebAssembly was more designed with a lot of this in mind from the beginning, right? Like it's not a, oh snap, we realized this problem, we're going to tack on this feature. It's instead, hey, actually, we've done computing for a long time. We understand all these sorts of things happen. Let's just lock everything down from the beginning and then allow runtimes to implement as much of functionality as they like to. And the beauty
Mhm.
of it is that because it's an interface, all the WebAssembly modules will be able to talk to it the same way. So it's not a matter of, oh, I need to go compile this code differently depending on where I want to run it. You compile it in the exact same way, and the modules will handle all these situations in the exact same way. And the
Mhm.
runtimes can dictate exactly how it is talking to the outside world, right? So we get that portability aspect while also keeping in all the security and as much customizability as we really want to have with it. So that's what is really interesting to me, and why it's really exciting where we are right now and just all the things we can do. And not to mention, like, this is just the beginning of WebAssembly. There's so much more that we're going to do in all of the different areas around performance security, right?
Mhm.
So I don't know, it's incredibly exciting to me.
Yeah, yeah. So it sounds like it's kind of akin to, you download an app and then it says, I need permission to access your camera. I need permission to access your microphone, and so on. So, but this would be even more specific. Like, you can only access my microphone when I'm on this website or I'm doing
It's
this thing, something like that.
It's totally possible. The unfortunate, thing about that is like it's 100% possible to implement that. The question is, will someone like if you're Google Chrome, are you going to implement that? Probably not. But they certainly could, right? But maybe some other privacy-focused browser might do something like that. That says, hey, actually, this code running can only access these 5 pixels, right? Like that's something, right? That's totally something that you can write. And WebAssembly
Mhm.
is going to be opening up a lot of opportunities for that sort of thing, which I
Mhm.
think is incredibly exciting.
Yeah, yeah. So what isn't WASM good for? We've talked about all kinds of things that WASM is good for. What are some non-WASM use cases?
Yeah. So things that you wouldn't want to use WebAssembly for, we've already talked about performance. Don't swap to WebAssembly for performance unless you're, sort of re-architecturing, your whole app. But I mean, outside of that, the beauty of WebAssembly is that it really is. Okay, so like I said, it's not an assembly language, but for all intents and purposes, it's sort of an assembly language, which means it's fairly general purpose, right? You can, for example, I work on a programming language that only compiles to WebAssembly, right? But that's okay. We don't need to necessarily say, hey, we're going to target, x86 to run on computers with Intel chips, or we need to target ARM to run on like those fancy new Macs, or maybe, tablets and things like that. Like that's
Mhm.
not something that we feel that we need to worry about because we can actually accomplish pretty much everything just through WebAssembly and through WASI, right? you can also implement WASI in a way that says, actually, no, just give full blanket access to all the system calls and just do everything. In which case, WebAssembly is just a target for general purpose programming, right? And you can just write everything in WebAssembly. Is it going to be as fast as writing, native code? No, it'll be a tad bit slower, but WebAssembly runs at near native speeds, right? But the trade-off for running, I don't know, 3% slower is that all of a sudden we don't have to worry about, oh, how does this work on Windows, right? Like that's not something that you have to consider, right? It's a matter of, oh, it is going to run everywhere. Any of the runtimes that support these, WebAssembly features is going to work. So there isn't much you can't do with WebAssembly. I think the important thing right now is don't jump ship too early. And that's sort of the thing I keep, reiterating, right? It's like in the future, you can do absolutely everything with WebAssembly. But right now, keep it to using it for all the use cases that you think really matter for you and for your application, right? But of course, if you're going to experiment, go for it, right? Like there's no reason not to. Like play around with it, see what you can do with it today, and just think about what you're going to be able to do in 3, 5, 10 years. And that's going to be a completely different story. But we definitely will get there. Folks are working on all of the problems to make it as general purpose as possible and solve as many people's problems as possible.
Yeah, right. Okay, so people can just hop into the magical sandbox and start playing around and seeing what they can come up with. And
yeah, I mean, absolutely. Of course, like some languages make it, easier than other languages, right? But there are pretty good guides and tutorials out there, right? Especially like if you're getting started with something like Rust, it's pretty easy. You just set a target, say, oh, I want to compile for WebAssembly, and then it says, okay, and then that's sort of it, right? Or using like, WebAssembly specific languages like AssemblyScript or Grain, right? You just sort of download them and you write a program and they spit out WebAssembly, right? It's pretty easy to get started. And I think that's a big scare for a lot of people right now is they don't realize how they can get started, how easy they can get started, right? I think it still seems very intimidating for a lot of people. How do I actually start writing some WebAssembly? How do I bring WebAssembly into my app? But there are folks like myself, there are plenty of other folks in the WebAssembly community who are working on this. We're trying to make it as easy as possible for folks to get into WebAssembly, start messing around, start getting it into their apps, right? Even here at Suborbital, right? We're making it dead simple to get into WebAssembly, where you don't even have to configure the languages yourself, right? You just download the CLI and say, I'm gonna write some Go, some Rust, some Grain, some AssemblyScript, some TypeScript, JavaScript, even languages that are being compiled to run in runtimes, right? And just say, hey, I want to do it, and then it figures it out, and it will spit out WebAssembly modules for you, and even run them, right? So there are plenty of folks out in the community that are making it, dead simple to get started with this stuff. Absolutely.
Right. Yeah, I'm just going to link our docs here in case anybody wants to try our version of how to get started with WebAssembly in a friendly way. And hello, Spot and Jake 100. Thank you for joining us. Happy to see you here. Okay, so we're winding down here. Okay, so you don't know what you don't know. And so what questions should I have asked that I didn't?
Yeah, that's a great question. I think we sort of spanned, a lot of the gamut. I think like maybe the only thing is sort of just like, yeah, what does the future look like for WebAssembly? Like, where are we going? I think is the only question. And what I'd answer to that is, I think we're going to see a full WebAssembly takeover, right? WebAssembly is working out in a lot of spaces. Like its portability nature is absolutely huge. The fact that the binaries are small is absolutely huge, right? So like we're seeing it in serverless computing, right? So the number of startups that have spun up around serverless WebAssembly and server-side WebAssembly is incredible. So we're going to be starting to see it there on the server side. Eventually, it's going to make its way back around to the browser. It's going to exist there. In fact, we were talking about Python in the browser, like the folks working on PyScript. People are so hyped for PyScript and running Python in the browser. And we're going to start seeing all these other languages in the browser, right? And so all of a sudden, apps aren't going to only be JavaScript in the browser. So there are going to be some new languages, some new players in the space. And so from, just front end to back end, not to mention, microcontrollers, right? Like I talked about running code on a light bulb, right?
Mhm.
Like, why would you do that in WebAssembly instead of just compiling to native code? Well, because it's freaking easy, right? Like if you have something like the WebAssembly micro runtime, Whammer, which runs on literally, you can get Whammer to run on literally anything, right? Then it's like, yeah, I'm going to write some code that's just going to run on all these tiny little devices. So from IoT to, there is like some contention around like blockchain right now, but even like blockchains are accepting it because it's a great way to have, tiny, modules of code that can run somewhere. So like we see that use case. Like WebAssembly is going to be in absolutely every single space. So, if you're not betting on WebAssembly, you absolutely should at this point, right? I think we've gotten past the point of it being so experimental to folks doing very real stuff with it now. So I think those would probably be most of my parting words.
All right. And so in our episode 2, we'll be getting into that even more about the future. We'll be talking about or getting answers to questions like what's the bytecode alliance, what's in script and what's binary, and how do WASM proposals work, and what is WASI. We talked a little bit about what is WASI today, and we can get into even more details next time. And we have some posts that we can link. These are previous streams and blog posts that we've had in the past. I will drop these links right here. And where else can people find out more about WebAssembly and the WebAssembly ecosystem?
Yeah, absolutely. So in terms of if you're trying to do literal WebAssembly, like just literal, like, assembly stuff, the WebAssembly community group and working group, they meet all the time. There are meetings throughout the week. So you can go to the WebAssembly org on GitHub and you can find out about all of those if you're trying to get into the nitty gritty. But I think if you're really trying to be a power user, the real secret sauce, and maybe this might be the best advice out of everything that I've said in this, entire stream, is go join the Discords for all of the projects of anyone doing WebAssembly. So that's,
like ours.
Yeah, like ours. Like join the suborbital Discord, right? Because you're just gonna find out about WebAssembly stuff. There are communities for like AssemblyScript and Grain. So like for folks like really like just on the ground, knee deep in WebAssembly, like they're talking about really interesting stuff all the time. Go join those Discords, right? I think those are gonna be some of the best places to go to just hear firsthand what folks are doing with WebAssembly, right? And of course, I'm sure like there's plenty of mailing lists and folks you can follow on Twitter. But I think definitely just being a part of the conversations, you're going to learn absolutely so much.
Great. Yep. And I've dropped a link to the suborbital Discord and some videos and posts. And I think we are all set for today. Thank you so much for sharing all of this information and for making it fun.
Yeah, absolutely.
Honestly.
I mean, thank you for being an excellent host. It's always great to, be around fun people who are just, excited about WebAssembly because I'm always too excited about WebAssembly. So whenever there's anyone at all who's somewhat interested in WebAssembly, I'm just so excited. So yeah, thank you so much.
Nice. All right. Well, catch you again soon. And thank you to everyone who has joined us today. And stay tuned for episode 2.
All right. Take care, folks.
Thanks. Bye.